Hello and welcome. You are watching Bhavishya and I am your host AP. Friends, today we are going to discuss about the pulse width modulation using DC motor. This is the circuit diagram of pulse width modulation using DC power supply experiment. You can see it content IC555 timer. Now let's sort the pin number 4 and 8. From pin number 4, positive terminal of power supply is connected, and from pin number 4 1 kilo ohm resistor connected with 5k pot, and another terminal of 5k pot connected with pin number 7 of 555 timer. Now from pin number 7 one 4.7 kilo ohm resistor connected with pin number 2, this name as RB. Now from pin number 2 1.22 microfarad capacitor connected with ground. Now sort pin number 2 and 6. Now you can see that here we completed half of the connection. So now let's for the other. Now connect between pin number 5 and 1 0.0 microfarad capacitor, or at the place of 0.05 microfarad you can use 0.1 microfarad. So connect 0.1 microfarad capacitor between pin number 1 and 5. Now pin number 1 should be grounded. Now from pin number 3 connect 1 kilo ohm resistor which is connected with NPN transistor, and the base of this transistor should be connected with this resistor, and this emitter is grounded, and this base is connected with resistor, and the collector is connected with DC motor, and this is the DC motor. One terminal of DC motor connected with this collector, and other terminal of a DC motor connected with pin number 8. Now let's see the requirement of this experiment. First of all, we required a breadboard. This is the breadboard, and DC motor which works on 0 to 12 volt. This is the 10k potentiometer. You can use 5k also. Here this black is grounded, red is positive terminal as considered. This is 0.22 microfarad capacitor, and this is 4.7 kilo ohm resistor, and we required 1 kilo ohm resistor. Here we required two 1 kilo ohm resistor. One is already connected with 5k pot. You can see here. Now this is the 555 timer IC, and you can see the 555 timer written on this IC. Now this is the transistor, and you should know the base, emitter and collector. So this is the emitter, this is the collector, and middle one is base. So here this is the, we use digital oscilloscope for the output, and this is 5 volt power supply, 5 volt DC power supply. Now let's connect according to the circuit diagram. So first of all, connect this IC555 timer on a breadboard, and according to the circuit diagram connect the remaining part of this circuit. So first of all we should sort this pin number 4 and 8. So we using yellow wire for sorting. So sort pin number 4 and 8. Here you can see we sorted. Now connect 1 kilo ohm resistor from pin number 4, which is already connected with potentiometer, and another terminal of this potentiometer connected in pin number 7. Now let's connect one 4.7 kilo ohm resistor from pin number 7 to pin number 2, means 4.7 k resistor connected between pin number 7 to pin number 2. So we are connecting by using wires. So let's, here we connect pin number 2 to 7. See, this is already, this is connected. Now from pin number 2 we connect 0.22 microfarad capacitor. So let's connect it. Here you can see here we connect this 0.22 microfarad capacitor between pin number 2 and ground. The other terminal of capacitor is grounded. So it's connected here, and next we have to sort this pin number 2 and 6. So let's sort it. So pin number 2 and 6 is sorted. Now our half part of the connection is completed. Now move to other part. Take a 0.1 microfarad capacitor and connect it between pin number 5 and 1. So the leg of this capacitor is small, so you can use wire, means you can connect this capacitor by wire. So not connect it. Here you can see we connected it at a pin number 1, and from pin number 1 to 6, here yellow wire used for 1 to 6 connection. Here we connected, sorry, between pin number 1 to 5, between pin number 1 to 5. This capacitor is connected between pin number 1 to 5. This capacitor is connected between pin number 1 to 5. Here we connected this 0.1 microfarad capacitor pin number 1 to 5, and now let's ground this pin number 1. So we use green wire for ground. Here pin number 1 is grounded. Okay. Now you can see clearly pin number 1 is grounded. Now take 1 kilo ohm resistor, which one terminal is connected from pin number 3 to the base of the transistor. So one terminal of resistor connected between pin number 3, and let's connect the other part of this resistor with transistor. So transistor emitter is grounded, base is connected with resistor, and collector for DC motor. Now connect this DC motor with collector of transistor. So one terminal of a DC motor connected with transistor collector, and other terminal is connected with pin number 8. So here you can say we connected, and now connect this power supply. So positive terminal of power supply should be connected between pin number 8. So this is okay, remove this, and this is the red wire is used for the positive terminal. So this positive terminal connected between pin number 8, and this negative terminal is connected to the ground. So here our connection is completed. Now let's check is it working or not. So switch the power supply and we can see that this DC motor is moving, and as we vary this potentiometer, the speed of DC motor is changing. That means our connection is perfect. Now what we have to do for output, we have to connect this digital oscilloscope, and here digital oscilloscope, here this is the positive terminal and this refer as a negative terminal. So connect this positive terminal with a red wire, and this positive terminal should be connected between pin number 3, and if you are connecting anywhere else, it might be not working. So let's see, we are connecting with the resistor, let's see it's working or not, and the negative terminal is connected to the ground. So this negative terminal is going to be ground. Now you can see here this negative terminal is grounded. Now let's see, switch on the oscilloscope and see will we observe this waveform or not. So before doing this experiment, you should know what is the theory behind it, and you should know how to operate this digital oscilloscope. Okay, now you can see here there is no output observed. Press auto set, then after pressing auto set you can see there is no waveform is observed. So let's connect this positive terminal with pin number 3. So as we connected pin number 3, oh wow, you can see here the output is observed, means waveform is observed. Now let's vary this potentiometer and see what the changes is going on in this output waveform. So as the potentiometer is changing, that means its voltage is changing and its waveform is also changing. So this mean is showing this potentiometer voltage. So according, you have to make observation table this voltage versus T off and T on. I would like to tell you that T on is upper part of this graph, and T on is upper part of this graph, and T off is lower part of this graph. According to theory, T off should be constant. So here you can see that this T on is varying only, T off is constant. So adjust according to your observation, adjust by using this time knob and voltage knob, and vary this potentiometer and take the reading. So here you can see we can change by using this. So now as you have to do, just vary this potentiometer and observe what is going on in this with T on, and note down that reading and make your observation table. That's it. In this experiment, nothing you have to do, very simple experiment. Okay, now make your observation table, calculation, theory part. So please read its theory before going to perform this experiment. You will understand what the things are going on. So good luck for your experiment.